Now suppose I have written 2 raised to power 4 as 16, and its logarithmic form can be written as log of 16 with base 2 as 4. Okay. So in place of this 4, which 4? This exponent 4, I can write log 16 with base 2, because value of 4 is log 16 with base 2. I can put this in place of the index 4. So my exponent form will result in 2 raised to power log 16 with base 2. Okay, and its RHS is 16. It will remain as 16. I have just replaced the value of 4 with log 16 with base 2. Okay, so as you can notice here that this is 2 and this is 2, means the bases are same, right? And answer is 16. So from here we arrive a very important property, which is first property, that log of any number x with base a, and this whole number when it is raised to the base a, this will always be equal to x. Okay, this is property number 1. For example, you may write, let us say any, you can say 7 raised to power log of, let us say 80, and it is 7, so it is always 80. Now you may change base to 17, this will again be 18. Now you can change the base to 171, this will always be 80. You can change the base to 171 upon 2, 170 upon 2, answer is always 80. Okay, so log a raised to power log x with base a will always be equal to x, right? Second property is that log of xy with base a is equal to log x plus log y. Base should remain same. In all the properties, bases are same. Okay, I won't repeat again and again that log with this and this, right? I will just pronounce this as log of xy is equal to log x plus log y, and this is called multiplication property. Multiplication property, and this is second one. Third one is your division property, and fourth is a special case of property number 2, that we will derive all these 3 properties. How we can arrive at this conclusion that multiplication in terms of logarithm, it turns into addition and vice versa, right? So second property is log xy with base a is equal to log x plus log y. Log xy with base a is equal to log x plus log y. Bases are same. Okay, so how we can prove this? We will use our first property, right? How we can use the first property? That by writing the first statement that xy is basically written as x multiplied by y. Okay, and I can write this xy and can raise the power to a. That means a raised to power log of xy with base a. Okay, this is basically xy written. Okay, this xy is just a raised to power log xy with base a, and similarly I can replace this x with a raised to power log x with base a. This is just x from property number 1 multiplied by a raised to power log y with base a. Okay, this is y. So x into y is xy. Now RHS is that here the bases are same. This is base a, this is base a. So if same bases are in multiplication, powers get added. Okay, basic law of indices, powers get added. So I can write this as a raised to power log x plus log y. Bases are same. A raised to power log x plus log y. Okay, exponents are added, and on LHS I have a raised to power log xy with base a. Okay. Now you may notice here that on LHS we have base a with some exponent, and on RHS also we have base a with some exponent. So on both the sides bases are same, so exponent should also be same. That means log of xy with base a must be equal to log x with base a plus log y with base a, and this is the proof of property number 2, that log x plus log y is equal to log xy and vice versa. Okay, and these are the laws of logarithm, means these are the properties for any value of a, x and y. Any means provided they satisfy the definition of logarithm, that a should not be negative, it should not be equal to 1, and similarly x and y should always be positive. If all these three numbers satisfy these properties, these conditions, then these are always true for any values of a, x and y. Right, just like we have laws of exponent, we have laws of logarithm also, which are these. This is property number 2. And as a word of caution, you can say note is that if it is written log x plus y with any base, let us say a, this is not equal to log x plus log y. Most of the students, they get confused that they can distribute this log into x and y. It is not this log is not a number in itself. It is a function. Just like we have sine x plus y is not equal to sine x plus sine y, if you know this fact. Okay, just like sine x plus y is not equal to sine x plus sine y, because this sine is a function. If you have written just sine, it doesn't mean anything. Okay, there has to be some input to sine, then only there is a meaning of sine of something. Similarly, we have log. This log is a function which is giving the logarithm of x plus y. If it is written just log, it doesn't mean anything. So we cannot distribute these. We cannot separate this x and y. Okay, so log x plus log y will be equal to log xy, not log x plus y. If it is written in some question log x plus y, so this will remain as log x plus y only. Please do not separate this with log x plus log y like this. Okay, fine. Similarly, the third property can be proved, that this is your division property. This is in case of division, that in the first case numbers were multiplied here, so we add these two logs separately, and we can subtract these two logs separately if there is a division. So log x upon y is equal to log minus log y, and in the same way, please do not do this, what, that log x upon y is not equal to, that you cannot separate this log into x and y. This is not equal to log x upon log y. We cannot separate this into x and y. Okay, please note this too. And these are the two basic confusions in these two properties, that most of the student, I find that they get confused and they attempt wrongly these type of questions. Okay, they remember these properties, that okay, log x plus log y is log xy, but the problem arises when they apply these laws in solving problems. Okay, this we are going to see in the next video, but let us prove the fourth one before that, that log of x raised to power n is n log x. Fourth one, that log of x raised to power n is written as n log x. Base will remain same. I'm not writing. Okay, just write base a. Okay, now how we can prove this? How we can prove this? So let us say log x plus log y, log x plus log x and so on plus log x, right? And this is written n times. Means you are adding log of x n times. Okay, now according to the property that log x plus log y is equal to log xy, means all these x will get multiplied. So I will write this as log of x multiplied by x multiplied by x multiplied by x and so on, lastly multiplied by x, and this is again how many multiplication are there? This is n times. Okay, so this will be log of, if a number x is multiplied n times, I can write this as x raised to power n. Okay, so LHS is you are adding log x n times, so LHS also I can write as n log x. Means if it is written log x plus log x, I can write this as 2 log x. Okay, we can add this. Just like sin x plus sin x is 2 sin x. Just like sin square x plus sin square x is 2 sin square x. It is just like an apple with an apple or 2 apples. Okay, so 2 log x, this we can do. So here we have arrived with the proof of fourth one, which is n log x is x log x raised to power n. And this is true for n belongs to any real number. Oh, sorry, it is belongs to, right? N belongs to any real number, not just integers. Okay, for example, log of let us say x raised to power 1 by 7, you can write this as 1 by 7 log x, and you can take any value x also. Means, for example, example number 1, example number 2, you can write as that if, for example, log 2 is, I do not know exactly the value of log 2, I think it is point, let us say, for example, I do not know, 213. Okay, I do not know exactly the value of log 2. Log 3 is, I think, 0.3010. So let us take for an arbitrary value of log 2 is this. So find the value of log 2 raised to power 1 by 7. Okay, so solution here is that log 2 raised to power 1 by 7 can be written as 1 by 7 log 2. That means, and log 2 value is 0.213. You can divide this by 7, means log 2 is 0.213 divided by 7, whatever is the value. Okay, 0.34 and so on. Okay, 134 something is the answer approximately. Okay, so these are the 4 basic properties, and out of these 4 also, these 3 are most commonly used in solving questions of logarithm. Okay.